This is a story about the government as venture capitalist. The Trump administration has announced it will invest $2 billion in 9 quantum computing firms.
The Trump administration taking stake in select quantum computing firms.
That entire ecosystem of quantum computing stocks like Rigetti and D-Wave all moving higher on the back of that news.
Really strong optimism on this quantum computing sector.
These investments will not be grants or contracts to buy from these firms. They will be equity stakes in the frontier technology of harnessing quantum physics to build an entire new form of computing, something talked about and researched for years, but that has remained stubbornly on the horizon. IBM by itself will receive half of the government investment. Sam Palmisano spent 40 years at IBM, rising to be its chairman and CEO. He was there when the company began its quantum quest.
I think the societal implications are greater than the financial investment. I mean, to put it in perspective, 3 decades ago, I invested in quantum and IBM research. So when I left the board, which was 20 years ago, I said it'll be there in 10 to 15 years. So I'm wrong again, wrong again. It's very difficult scientific problems: disease, energy, financial markets, logistics, national security, cyber. It has the technology to do things that would have taken days on a supercomputer that IBM built, could maybe take an hour or 2, literally. I mean, there's things that are intractable that we deal with as a society, climate change, those kinds of things that are heavily scientific and I'll say physics in this field, can all be addressed, assuming, where they are actually does happen in the next 2 or 3 years.
The potential may be enormous, but what exactly is quantum? And why has it taken so long to realize the potential we've been promised? Last year, we talked with Jamie Garcia, Director of Strategic Growth and Quantum Partnerships at IBM. A PhD chemist, she's working at the Cleveland Clinic, where IBM has installed one of its quantum computers with the goal of transforming healthcare.
Quantum computers are just a totally different paradigm to calculate solutions to problems. And so what most, experts have done today that are studying quantum computing for different application spaces is to really sit down with the math and figure out, are the algorithms here that I can use and that I can exploit using a quantum computer going to bring me any sort of advantage over what can be done today in classical sort of state-of-the-art techniques.
At the core of classical computing are bits, single pieces of information that can have the value of 0 or 1. But quantum technology relies on qubits, a unit that can have multiple values simultaneously. It's like holding a coin in your hand that is heads, tails, and everything in between until you open your hand to check. Physicist Jerry Chao is IBM's CTO of quantum-centric supercomputing, working at the Thomas J. Watson Research Center just north of New York City.
Really fundamentally, there's a different math, right? It's the mathematics of quantum mechanics that is governing how you actually manipulate these quantum bits, which then gives rise to a whole host of different opportunities for algorithms and types of problems that you can actually solve using quantum computers.
A turning point in IBM's efforts to make quantum computing a reality came when it made it available to the world on the cloud.
2016, the IBM quantum experience was really a pivotal moment for us in terms of getting quantum computers for the first time out onto the cloud and into the hands of anybody, really people, right? What's interesting is that before that period, I'd say it was really much more in the realm of physics, right? That we were doing experiments on small devices, qubit devices that we were looking at, understanding how they worked, trying to make them better. But we didn't have any kind of real thought about how is this going to be used for computation.
In the 9 years since you put quantum experience up there, what have you learned at IBM?
There was a whole lot of people out there who wanted to touch and learn about quantum. I think we were sitting there that first night after we launched it, watching these circuits coming in, and people were actually running things, and we were like, oh wow, this is picking up some steam here. And then to this point, we've had tremendous uptake in terms of using the platform to actually generate new papers and research. Thousands of papers have been generated, which would have been impossible for us to do just as individual scientists or researchers studying these devices in our own lab and working with other scientists in collaborations.
And in success, that community could go places that classical computing, even using the large language models of AI, could never take us.
So it's not just speed, it's actual accuracy. When we're using classical, no matter how infinite we get, it's an approximation.
Right, absolutely. It's absolutely not a question about speed. The whole point of the quantum computer and what it can do is that it can give us the ability to actually get potentially more accurate results, also get results that otherwise are unattainable using a classical computer alone.
Companies like Google, Microsoft, and Intel are all exploring the potential of quantum computing. But there's also a new group of contenders, startups, that are betting it all on the hope that quantum tech will one day become profitable. One of those firms is Maryland-based IonQ. Its CEO is Niccolo De Masi, who believes he has the best horse in the race.
We supply quantum computers to our both federal, state, and commercial customer partners. We also provide quantum key distribution, and we do that both on the ground and up in the heavens. Quantum key distribution is effectively quantum cyber security. And we're very focused on this not being just proof points in the lab, but doing useful quantum advantage examples for our customers and embedding ourselves into their workflows on an ongoing basis.
The potential may be great, as are the investments being made. But when can we expect to see these potentially dramatic results? It turns out that depends on whom you ask. IBM has made getting to quantum advantage in the real world a strategic priority and has a timeline of getting there in a big way by 2029.
Our roadmap really shows the detail in terms of how we want to get from today to 2029. In between, we have this real important milestone also that we believe that with the community we'll be hitting quantum advantage, right? Where there'll be some problems and claims of advantage where we'll see quantum really surpassing any classical methods of solving certain types of problems.
IBM says it's on track to have quantum computing pay off in a big way by 2029. But IonQ's De Masi says they're already there.
So our machines we announced on September 12th at our Analyst Day are 36 quadrillion times more powerful than anyone else's machine, and that gap is increasing. Not only do we believe we are 5 years ahead of anybody else in the quantum computing business, whether it's government programs, adversaries, or commercial companies, but we also have the lowest unit economics. So we're able to build a fully fault-tolerant 2 million qubit system and keep our cost of goods sold under $30 million.
The quantum race is on, and the promises are big. But the winner is in the eyes of the beholder. IBM says it's ahead because it has more total qubits in its machines. IonQ says it's not the number of qubits, but the number of algorithmic qubits, putting it in front. Previously, these were questions for investors to weigh. But now the government has entered the race and placed bets on 9 quantum computing companies. Those left out include big players like Google and Microsoft, and smaller contenders like IonQ. Google says that funding from the government would have come with conditions that would have slowed down its progress.
Why do we need the government to participate? Why can't the private markets take care of it on their own?
If you go back to the original investments in the internet, it was ARPA, and then it became ARPANET. It was basically a link to connect the scientific laboratories and the academic research universities to exchange information on what they were doing in research. That became the telecommunication backbone for the internet. The government didn't create the digital economy. The government created the infrastructure. But built on the infrastructure were the companies, the ecosystem for innovation, as well as investment. An example of where things haven't worked so well had to do with an energy company back in the 70s under Nixon. There was an energy crisis. That failed miserably, needless to say, because they tried to pick a company. So when the governments, not just here, when the governments around the world, look at state-owned enterprises if you want to go to China and places like that, when they try to pick companies, their history says they aren't as successful as when they create the environment for the private sector to be successful.
This is an equity investment from the government.
Yes, correct.
But there's a range of companies that they're investing in. But it's equity participation, which is different from what I have with ARPA. That was a grant.
Yes, correct. Yeah, it's absolutely right. And this is where I think the model is challenged, because when you make an equity investment, maybe they're spreading their risk. I mean, like a pro-growth equity PE firm. But at the end of the day, you're picking. The risk associated with picking, as in the past, is that government doesn't do a very good job of operating. And government doesn't have a long-term attention span. This technology is going to take 10, 15, I'm already in for 30 years, right? I mean, so, you know, you need stability in that regard, and that's where government struggles in operational detail. They do policy, right? They can make grants, do research, and they need to fund long-term stuff, but they're not strong at actually running companies, and that's where they failed.
To most of us, $2 billion sounds like a lot of money. But when you compare that with some of the investments being made right now in AI,
yes.
I mean, $850 billion.
This is, yeah.
So is this priming the pump for investors? Is this a way of the government saying we're willing to invest and that will encourage other investors to come in?
I think the reason that why $2 billion is nothing is what's going to take. Just go through the development cycles. When they talk about a hybrid model for quantum, right, what they're talking about is marrying this quantum advantage, the technology, to the traditional approaches, which is cloud and AI. But it's not commercial computing, right? It doesn't have what you need to make this thing a robust commercial system. The data management, memory management, backup and recovery, all the things you expect, right? Accuracy of your answers and things like that, that you expect if you're running a hospital or a bank or whatever it happens to be. I don't think is going to be there in 2 to 3 years. I mean, they're working on it like crazy, but I think this thing's got a way to go from a financial perspective. So $2 billion, I mean, it's a start, but it's certainly not going to be the finish.